Yeah, what channel? So, all right, so right, so we looked at current, we looked at how to find current, we looked at how to take a circuit and draw it using circuit symbols only. Yeah, we were talking about the diode. The diode allows current to flow in one direction only, right? Right? What's the next one? What is called that there? What are you doing here? Stop edge up anything now. Okay, that's on YouTube. All right, that's not on YouTube. All right. Yeah, so what is called this again? What is called this? The fuse, and what's the fuse used to do? Control the amount of current, right? So if the fuse rating is 5 amperes, what will happen? Right? Any current beyond 5 amperes will blow the fuse, right? All right. So you have your ammeter, you have your L. What's this again? What's this? That is used to adjust your, right? It's used to adjust the resistance, right? It's also called the rheostat. Nice shot. Also called the rheostat. Right. You have two types of supply, alternating and direct. Well, okay with that? So you have alternating and direct supply. Right. How do you move from alternating to direct? You use the diodes, and it's called what? What's the process of moving from here to here? Yes, very good. It's called rectification. It's called rectification, but we only have to learn halfway for now, right? Rectification. To go from an alternating supply to here to a direct supply. Right? Right. You have series and parallel circuits. How do you know a series circuit? How you know if two components in series? What you look for? Huh? How you know that? Watching it? Yeah. You look for no, but how you know if it's series? Right next to each other, and these two right next to each other. Right. So basically, once the same current flowing through them. So basically, once it have one loop, right? Once the current only has one direction to flow in, right? It means that the current through this lamp and this lamp would be the same. So those two will be series. But here now, when the current reaches there, it's going to split up. So once current splitting up, we have different values. Sometimes it can be the same value, but the current split up. Once the current splits up, it means that these circuits here will be in parallel. All right? As a quick example, tell me what you think here. This is R1, this is R2, this is R3. R1 and R2 are in what? R1 and R3 are in? R2 and R3 in? Suppose it combine R2 and R1. That'll be in parallel with R3. That's okay? Yeah? Kavish, you okay with that?
Yes.
One more little circuit here. Hey, whose phone is that? Who's that? Helena, that's yours? Right. What about R3 and R5? R3 and R5. R3 and R5. Parallel. Parallel. What is here? Let's make up some numbers. Right? When the current reaches here, let's call that I, right? And the current is going to split up here and here. That's I1 and that's I2. And then it will join back here to give you I. So look at the current going through R3 and look at the current going through R5. Are they different? Yeah. One is I and one is I1. So the currents are different, so the circuit is parallel. That's okay? What about R3 and R4? R3 and R4 is parallel, right? Because the current does split up I1 and I2. What about if you combine I1 and I2? Sorry. What about if you combine I3 and I4 into one? How will that be with R5? Series, right? Are you calling me? Right? It means that two. She reached? Right? But she reached late, so she has to wait. All right, next one. So that's series and parallel. Tell me what this circuit is used for. Coming back. What's that circuit used for? Right. Yeah. What is this circuit used for? Right? Sorry? Something else a little more. A little more than that. It's a standard circuit that we have. Very good, Naisha. It's a standard circuit that we need to learn. It's right there in the heading. Right. This is the graph that we use to get the IV characteristics. Right? Yes, in this case, we'll be able to light the lamp, right? But if we adjust the rheostat, we'll get current and voltage readings so that we could draw all these graphs. You can draw the graph for a resistor. I don't have the graph for filament lamp. Yeah, look at it. Right? So that's the lamp. That's the circuit used to obtain the current versus voltage graph, the IV graphs. Okay? So if a question asks you, draw the circuit for the to obtain the IV characteristics, this is the circuit you have to learn. Right? The voltmeter connected in. Sorry, the voltmeter connected in, the ammeter connected in, and your rheostat, right? Or variable resistor. The purpose of the rheostat is for what? It's to adjust the readings so you can get more than one current and voltage reading, right? Question. What's the gradient of a voltage versus resistance graph? Sorry, voltage versus current graph. what is the gradient of that graph? Resistance, right? Always remember, gradient is what? Gradient is the quantity on the y divided by the quantity on the x. So what is V over I? What is V over I? R. Right? So if you plot a graph, you know how to get resistance, right? Here are some other formulae that you need to learn. You need to know W is electrical energy, right? So electrical energy is Q by V, or VIT power IV, or V squared on R, power loss I squared R. Make a note of that because we're going to use that just now. Power and I squared R power loss. Are you okay with that? And the W is called electrical energy, right? W is called electrical energy. All right. So, before we start questions, very, very important. Most important table. It shows us how to handle series and parallel. It shows us how to handle series and parallel. Copy down that table. I know you probably have it already. Right? You can copy it up. Let's jump straight into the question. All right, so we're doing a whole year, right? To the 2004. Right? Of course, you're going to need this, right? So you have to identify where is series, where is parallel, and work it out, right? So always remember that voltage in series splits up, voltage in current in parallel splits up, right? Remember that. Voltage splitting up in? Oh, what does it mean? So it means something like this, right? If I give you a supply, a voltage supply, and I give you like 2 resistors in series, if you were to find the voltage here, you remember when I did this simulation? No? Our YouTube video on it. I did that last week, right? You can take a look at it, and I've did some example with numbers, right? But here's what it means. If the voltage here is, let's say, 12 volts, and you have 2 resistors, when you find V1, it might be 4, and the next one is 8. So it means that the voltage being supplied splits up across the resistors in series, right? But if I had a parallel circuit and I find the voltage, it'll all be the same as the supply. Okay? And current here, if the current here is 2 amperes, then the current here is 2. Then the current here is 2 and current here is 2. So the current everywhere is 2. That's what they mean by current in series is the same. Okay? And if a parallel circuit, well, vice versa, right? All right, so let's go back to all year. Let's do 24. 2004, I mean. 2004. Right, we're using power and thing, right? So let's take a quick little glance at the power formulas. Take a quick little glance at your power formulas, right? We're now choosing. All right. Try that there. Sorry. Lena, I'll take away your phone, right? Right, Lena. So remember to take away your phone. All right. So what type of circuit you have there? Hey, right? So you have a series circuit, right? They told you that you have a 12-volt battery supply, 400 amperes flowing. The battery supply is 400 amperes, right? 400. That's why I get what's up. Hey, don't forget my way. Talk to the man tomorrow. Tomorrow, right? 400 amperes. 12 volts, and calculate the PD across the motor. PD is potential difference, which means voltage. So watch this here. If you connect a voltmeter here, the voltmeter measuring voltage, right? But really and truly, it's measuring the potential here and minus in it. So this value here that the voltmeter gives you is really called potential difference. So PD and voltage mean the same thing. All right? Right. So we need the PD across the voltmeter. Sorry, across the motor. So look back at your formula. How do we find voltage? How we know about voltage again? Voltage what? In series. Everywhere handy in the screen. Yeah, voltage in series what? Splits up, right? So the 12-volt supply is going to split up here, here, and here, and here. So it has 4 places it's going to split up. Any ideas how to get the voltage across the motor? The motor's M. Any ideas? Before I pick on somebody. How we get the voltage across the motor? Huh? Right? Justin said to calculate the voltage here, 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 and then minus it from there. Did that work? Alena, am I making sense? Sure. It could be wrong enough. Correct. That could work. So you could find total resistance and then find the voltage, or you could find the voltage for each one. Right? So find the voltage across the 0.005 ohms. What's the formula you're going to use to find voltage there, Jaden? Huh? V is equal to what? You write it down, it's just huh? IR, good. Current is, so what we know about the current in each system? It's the same, right? So we know the current in the first one, second one, and third. Right? So find the voltage across all and minus it from the 12, right? That's one option. Huh? So you find the voltage across each one of them, and then the minus. Or you can find total resistance and then find the voltage. Right, what's the option? Find voltage back. So what do you do? 0.005. Oh, it was. All right, so what do we have? So the voltage here is equal to 400 by 0.005, which is 2, right? Here is 400 by 0.004, which is 1.6. And then here is 400 multiplied by 0.01, which is 0.4. So therefore, the PD across the motor will be 12 minus 2 plus 1.6 plus 0.4, which is, right, which is 8 in total, right? Nice. So the motor alone taking 8 volts. Right, anybody saw a different way we can work it out? All okay online there? Samira, you okay? Very good. Naisha, Elizabeth, good. Anybody saw a different way? Anybody seen something else that we could do? Safir? Anything else I could have done? Add up the resistance first. Yeah, right? Yeah, that can work. Add up the resistance and then find the voltage across that. That can work. Nice. Power being supplied. What's the formula there, Vishal? What you're going to use for power being supplied? Yeah. Pardon me? Very good. What's the formula? You just write it down. You can look back. I by V, you say? Yeah, I'll take that. I by V. So that's 400 by 12, which is 4,800 watts. Yeah. That could work. Yeah. What's the formula? Let me pick somebody online here. Let me see. Kiran. What's the formula we're going to use for power lost by the conducting wires? Dissipated means lost, right? What's the formula we're going to use? Not too sure. Check back the list now. Anybody can help him? What are we using for power loss? You're just V2, make it up your own. I squared R, right? Right? I squared R. Right? Check back the list right here. Power loss means dissipated means loss, right? I squared R. So I is 400 squared by R is what? 0.01. R is the total resistance, right? So you have to add up all. I don't have space, so I just write in 0.1. No, so sorry, 0.1. 0.1. 0.01, sorry. How much is that? 1,600 watts? 16? No, it's 400 squared. Right, 400 squared by 0.01. 1,600? Nice. Right, so I want somebody to figure out the last part now. Power used by the starter motor to crank the engine. Let's pick on who I'm pick on for a while. Let's see. Pick on somebody else here. Petal, what do you think? Power used by the starter motor to crank the engine. That's part 4. Petal, what do you think there? How are we going to get power used by the starter motor? 2 ways they can do it. An easy way and a slightly harder way. Petal, there? Not too sure. All right, that's all right. Anybody can help her? Right, Elizabeth said power supplied minus power loss. Yes, right? So one of the methods is power supplied minus power loss. That's 3,200, I think. Right, there's a next way. Very good. Right? Next way is to use current by voltage. Current is 400 and the voltage across this motor here is 8. 400 by 8 is the same value. Very good, I'm Justin. Elena, you get through there? You understand that? You're sure, because next one is yours, huh? You're on 0. All right. Define the potential difference between the ends of a conductor. What will be a definition for that? Define the potential difference between the ends of the conductor. If you had to make up your definition for that. A little more than that is 2 marks, 3 marks. Yeah, what you would say? The difference in? Right, so what you could say is that potential, wait, anybody online have anything? What do you think could be a good definition of potential difference between the ends of a conductor? Anybody online? I know you're typing. All right, so one person said here the difference between the rate of flow of electrons. Okay, I like this one. Right, so Naisha said is the energy converted from electrical to other forms. Right, so here's what you can look at, right? If you have something here, you have a potential here, let's call that P1, and a potential here, right? If you find the difference in potential, that'll be the PD, right? So what the potential energy is, what the potential energy between 2 points is the change. All right, then. Right, it's a change in energy from electrical to other forms. The change in energy from electrical to other forms per unit charge. Per unit charge. The change in electrical energy. Sorry, the change in energy from electrical to other forms per unit charge. Or the change in electrical energy to other forms per unit charge. You all remember this formula? W is equal to QV. So V is what? So V is W and Q, right? So voltage is energy change per unit charge. That's okay, right? And you could tell them the SI unit is in joules. I mean energy. Sorry, the SI unit is volts. Sorry about that. The SI unit is volts. Right. Anybody remember this? Explain why voltmeters used to measure potential difference must have very high internal resistance. Anybody remember the answer? Why is the internal resistance very high? Sarah, any idea there? Your hand up. Sarah, any guess? Huh? Right there. Correct, Vikash. Yeah? Why is the voltmeter reading? Sorry. Why does the voltmeter have a very high internal resistance? Right? So imagine this. Imagine you have current flowing here, right? If the resistance here is low, then it will pull current out of the circuit. Right? So therefore, the conversion of energy from here to here will not be accurate, right? Because some of the electricity is pulled out. But if the resistance here is very high, then no current will flow down there. Little or no current will flow there. So it means that you'll get a correct representation of the potential difference across the lamp. Right? So write this down. Write this down. The internal resistance is very high. The internal resistance is very high, so that the voltmeter does not. The internal resistance is very high, so that the voltmeter does not pull any current out of the circuit. So that the voltmeter does not pull any current out of the circuit. And hence, give an accurate potential difference reading. And hence, give an accurate potential difference reading. All right, let's finish up with this here. Try the first one. How many dry cells needed? PD reading. Potential difference reading. What year is this? Jan 2007. Ready? How much bulbs needed? Right? The answer is should be so much needed. Why say 5? Right, good. 7.5 divided by 5, right? Next one. 7.5 divided by 1.5 here. Calculate the power supplied if the bulb draws 1.2 amperes. Find the power supplied fast. Christian, work it out. Sure. How much you get there? Power supply is what? Come on, people now. What are you doing there? Oh. Do the question now, Vishal. Right, the bulb draws 1.2. What's the formula we use in here, Christopher? So the formula is what? Here's IV, nice. So that's 1.2 by 7.5, which is how much? 9? All right, 9 watts. Calculate the resistance of the bulb one time. Calculate the resistance of the bulb. What's the resistance? Huh? V over I, yeah? So the resistance is V over I. How much is that? Well, again, you online, so we just find the resistance now, right? We know the voltage 7.5 and the current 1.2. What's that? Dimitri got 6.25. Anybody else got that? Right, please get the habit of writing the SI unit, please. 6.25 what? Ohms. Nice. I think it have one more part. 2 of these bulbs are connected in parallel. Draw a circuit. Fast, fast, fast. 2 of these bulbs are connected in parallel to the same voltage source. Draw a circuit. Fast. Parallel circuit. We're using 3 cells, huh? That's nice. But they are not. Huh? Yeah, that's it. I have no more. I would have give you more, but the time on now. Yeah. How much will I get there? 2 bulbs, right? Circuit diagram. How many cells we had again? 5 in the beginning, so that's 1, 2, 3, 4, 5. And then you have two bulbs in. 2 bulbs in parallel. That could work. Right, and a parallel switch, right? Make sure you have a little switch, right? Right, next day we'll do a longer Kahoot because I want to test all the other topics as well, right? And we will continue with electricity and then do some magnets, right? If I'm not mistaken, we would have covered most of the years, right? So I'll look back. Yeah, I'm pressing the gate now. Okay, all right, all you.